Imagine this for a moment. You are standing on the ground on a beautiful sunny day. Everything around you is flooded with light. The sky is blue, the clouds are white, the grass is lush green. Everything is so clear that it almost dazzles your eyes. Now imagine that you are flying into space. Your spacecraft leaves the atmosphere of our planet, and suddenly something strange happens. Even though you are closer to the sun, everything around you becomes darker. Not dark because it is nighttime, but dark in a completely different way. The sky is pitch black, space is pitch black. There are only small stars twinkling in the distance, and the sun itself hangs like a bright sphere on a black canvas. It is strange. You are closer to our star, yet there is very little light around you. How can this happen? Why is it brilliantly bright on Earth, while space is as black as ink? This question has confused millions of people. Today, we will reveal the astonishing truth about one of the strangest properties of our world. To understand this mystery, we must first understand one important thing. What is light, really? Many people think that light is a kind of fog, that sunlight is some sort of substance emitted by the sun that fills all the space around it. This is completely wrong. Light is made up of special waves or tiny particles moving at high speed. They do not remain in empty space. They travel straight ahead until they collide with an object. When they collide with an object, one of two things happens. They either reflect and continue moving in another direction, or they are absorbed by the object and transformed into heat. And this is where the story really begins. When rays of light travel from the sun to Earth, they pass through space. Space is almost completely empty. It contains almost no matter. Across the vast distances between planets and stars, there are only a few individual particles drifting around. The rays of light collide with emptiness. They travel in straight lines, unnoticed by anyone. If you were standing in space, on the side of the beams of light, you would not see them at all. They would rush past you without reaching your eyes, so you would see pitch black darkness. Now imagine the beams of light approaching Earth. Everything changes here. Our planet has an atmosphere. This is the layer of air surrounding Earth. This layer of air contains many different kinds of particles: oxygen molecules, nitrogen molecules, water droplets, dust particles. When sunlight enters this layer, it collides with these particles. And here is what happens. Every particle struck by a ray of light begins to shine. Of course, not directly. It simply reflects the light in different directions. Part of the light continues in its original direction, while part of it is reflected to the sides. So when you stand on the ground and look up, your eyes do not receive only direct sunlight. They also receive light, reflected from millions of particles in the air. Light comes from every direction, which is why everything around you is bright, why you can see the sky, and why clouds are white instead of black. Every cloud is a gigantic collection of tiny water droplets. These droplets reflect light very well. Light comes from the sun, and they scatter it in all directions. Part of this light reaches our eyes, and we see a beautiful white cloud. But in space, everything is different. There is no air, no clouds, no particles to scatter light. So if you stand in space and look away from the sun, you see only pitch black emptiness. Light does not reach you from the side. Light only travels away from the sun, and only in the direction it is moving. If you turn your head directly toward the sun, it will be so bright that it blinds you. But everything around you will be pitch black. This explains a remarkable thing. The moon has no atmosphere. The moon is Earth's satellite, and Earth is also located in space. And when astronauts traveled to the moon, they saw an astonishing sight there. Even though the sun shone very brightly, the sky above the moon was pitch black. Not blue like our sky, but black. And in that black sky, you could still see the stars even during the day. That is because there is no air on the moon. There is nothing to scatter sunlight. Therefore, light only illuminates the places where the direct rays of the sun strike. Everything else remains in darkness. Astronauts who set foot on the moon told remarkable stories. They said that shadows on the moon are very strange. On Earth, we can see different objects in the shadows. If you stand in the shadow of a house, you can still see what is beside you. That is because the shadows are filled with diffuse light. Light comes from every direction. That is why darkness is never completely dark. But on the moon it is different. If an object is in shadow, it becomes almost invisible. Lunar shadows are completely black. This is because there is no diffuse light. If a shadow is not directly illuminated by the sun or reflected from another surface, then absolutely no light reaches it. This created major problems for astronauts. They worked under very strange conditions. One side of their suits shone brightly under direct sunlight. The other side was almost invisible because it was in shadow, and there was a very clear boundary between the two sides. Unlike on Earth, where everything gradually transitions from light to shadow, here there was a sharp boundary. It was like a flashlight in a completely dark room. Whatever the flashlight illuminated was clearly visible. Whatever it did not illuminate was invisible. But why is the sky on Earth blue? This is another fascinating part of our story. When sunlight is scattered in the atmosphere, it is not scattered evenly. Light is made up of many different colors. Combined together, they create white light. But when this light passes through the air, different colors react differently. Blue light is scattered much more strongly than red or yellow light. It reflects from air particles in many more directions. That is why when we look up at the sky, we mainly see blue light. This is blue sunlight scattered from the sun. It reaches us from every direction in the sky. And when the sun is low on the horizon, for example at sunset or sunrise, its light passes through a much thicker layer of atmosphere. Most of the blue light is scattered before it reaches our eyes. Mostly red and orange light reaches us, which is why sunsets are red. This is not because the sun changes color. The sun is always the same. It is because the atmosphere filters the light. The more air sunlight passes through, the more blue light it loses along the way, and the redder it becomes when it reaches our eyes. This explains another strange thing. If Earth had no atmosphere, our sky would be pitch black. Even during the day, you would be able to see the stars at the same time as the sun. It is frightening to imagine. A completely black sky with a bright white disk of the sun in the middle. No clouds, no blue, just a black abyss with a burning sphere inside it. The atmosphere is the beautiful canvas that makes our sky vibrant and beautiful. Without it, everything would look like the emptiness of outer space. Life on Earth largely exists because of this layer of air. It not only provides us with oxygen to breathe, but also makes our world beautiful. Speaking of the atmosphere, many people think that it is very thick, that it is a gigantic layer of air stretching upward for an enormous distance. This is not entirely true. Most of the air lies in a relatively thin layer, close to Earth's surface. If the entire atmosphere were compressed into a single dense layer, it would be only about 10 kilometers thick. Compared to the size of our planet, this is quite small. Earth has a diameter of more than 12,000 kilometers, but the atmosphere is only 10 kilometers thick. It turns out that all life on Earth exists within a very thin layer above the planet's surface. It is like the thin skin on a giant apple, and this thin layer creates everything we see: blue skies, clouds, sunsets, rain, rainbows. Now let us return to space, where there is no atmosphere. All of these things disappear. It is a strange place, full of contradictions. On one hand, it is incredibly bright. Direct sunlight in space is much stronger than on Earth. Here, part of the light is absorbed by the atmosphere, while in space, none of the light is absorbed. Therefore, if you place something under sunlight there, it will heat up to a very high temperature. Astronauts must protect their suits from this heat. Otherwise, they would quickly overheat, which could threaten their lives. But space is also very cold in shaded areas. When an object is in shadow and does not receive direct sunlight, it cools down very quickly. Heat escapes into space, and no new heat is supplied. The temperature drops below 0 degrees Celsius. Therefore, astronauts must work under these extreme conditions. One side of their bodies is extremely hot due to direct sunlight, while the other side is very cold because it is in shadow. This places a great deal of stress on the spacesuit. The suit must protect them from both overheating and extreme cold. This is a complex engineering challenge. Many people, when they first see photographs taken from space, are surprised by something else. There are no stars in the photographs taken from the moon. Astronauts took many photographs from the lunar surface, and in these photographs, you can see Earth, you can see the lunar landscape, you can see the astronauts themselves. But the sky above them is pitch black and empty, with no stars. Many people think this means the photographs are fake, that astronauts never set foot on the moon, that everything was photographed in a studio. But this is not true. The reason is very simple. The stars cannot be seen in the photographs. When taking photographs on the sunlit surface of the moon, you need to use a fast shutter speed. Otherwise, everything in the image will be washed out white. With a fast shutter speed, the faint light from the stars does not have enough time to reach the film, so the stars cannot be seen. If photographs were taken at night on the moon with a long exposure time, the stars would appear much more clearly than when photographed from Earth. This raises an interesting question. Why can we see stars? Stars are gigantic burning spheres of gas, just like our sun. They are very far away from us. Their light takes years to reach us. From the nearest star, light takes about 4 years. From other stars, it takes hundreds and thousands of years. And then that ancient light reaches us and enters our eyes. We see a star as it existed many years ago. When you look at a star at night, you are looking into the past. You are seeing light that left that star a very long time ago. That star may have gone out long ago, but we still see its light. In space, you can see stars that cannot be seen from Earth. The atmosphere of our planet not only scatters sunlight, but it also makes it difficult to see faint stars, especially during the daytime, when sunlight completely overwhelms their faint glow. That is why astronomers often launch telescopes into space. Space has no atmosphere. There, you can see stars both day and night. You can see very faint stars, very distant stars that are completely impossible to see from Earth. This gives scientists the opportunity to study distant regions of our vast solar system. By the way, there is something interesting about stars. When you look at a star from Earth, it seems to twinkle, shimmer, and change brightness. This is not because the star itself is shimmering. The star remains fixed in its place for billions of years. It does not change. The twinkling is caused by our atmosphere. The air between the star and our eyes is constantly moving. Warm air currents rise, cold air currents sink. When light from a star passes through these shifting layers of air, it is bent slightly. This creates the twinkling effect. In space, stars do not twinkle. There, they shine with a steady, gentle light. There is one more remarkable thing. On Earth, we can see only the stars that are relatively close to us. We cannot see most of the stars in our solar system. They are too far away. Their light is so faint that the atmosphere completely blocks it from reaching our eyes. But in space, you can see many more stars. If you stepped out of a spacecraft at night, on the side facing away from the sun, you would see countless stars, streams of light, bands of light made up of millions of tiny points. It is incredibly beautiful. Astronauts who have witnessed this sight with their own eyes say that nothing is more beautiful than the night sky in space. It is the most spectacular sight you could ever see. Now let us consider another interesting thing. If space is so dark, why does our Earth appear so bright from space? When you see photographs of our planet from a space station, it shines like a beautiful blue-green sphere. But in space, everything is dark. So where does the light on Earth come from? The answer is very simple. Earth does not shine by itself. It reflects light from the sun. Every object on our planet reflects sunlight. The oceans reflect blue light. Forests reflect green light. Clouds reflect white light. Snow and ice reflect a great deal of light. And all this reflected light is sent back into space. That is why Earth looks bright even against the dark background of the universe. The same is true in reverse. When you look at the moon at night, it does not shine by itself either. It simply reflects light from the sun. Part of this reflected light reaches your eyes, and you see the moon. Without the sun, the moon would be invisible. It would be only a dark sphere against the black sky. All the planets in our solar system work in the same way. They do not produce their own light. They reflect light from the sun. And only stars produce their own light. They create light themselves because of special processes taking place inside them. The connection between light, atmosphere, and space tells us something important. Our world is structured in a very remarkable way. Every small detail matters. Without air, there would be no blue sky. Without clouds, there would be no beautiful sunsets. Without an atmosphere, the world would have no color. And all of this works only because there is a thin layer of air above the surface of the planet. This layer of air creates all the beauty of our world. Without it, we would live in a black and white space with direct sunlight and harsh darkness. It would be a completely different place. Scientists use knowledge of light to study other planets. They observe the light reflected from distant worlds. Based on the color of this light, they can determine what exists on those planets. If a planet is green, it may have vegetation. If it is blue, it may have water. If it is yellow or brown, it may be a desert world. Imagine this for a moment. We can learn a great deal about other worlds without ever visiting them. We only need to carefully study the light coming from those planets. And here is another fascinating thought. The universe around us is vast. It contains billions of stars. Each star is similar to our sun. Many stars have planets orbiting them, and perhaps some of those planets also contain life. Perhaps there are other intelligent beings who also look up at their sky, who also see their sunsets, and who also wonder, why is space dark, but our planet so bright? If they have an atmosphere, they would see effects similar to ours. Their sky would also glow during the day. Their sunsets would also be colored red. Their stars would also twinkle in the night sky. This connects us to them. We all live under the same laws of nature. The simple question of why Earth is bright and space is dark opens up an entire world of wonder. A world where everything is connected. A world where every object has its own meaning. A world where even the simplest phenomena reveal depth and complexity. This is the beauty of science. Science shows us that our familiar world is far more interesting than it appears, that behind every ordinary phenomenon lies a remarkable story, that we do not need to search for miracles in distant regions of the universe. The miracle is right here, around us, in every ray of sunlight, in every blue sky, in every beautiful sunset. The next time you look up at the sky, try thinking about all of this. Think that all the blue light around us is the result of light scattering from tiny air particles. Think that without this thin layer of atmosphere, we would be living in the darkness of space. Think about how fortunate we are to live on a planet with such a wonderful glowing shell. And perhaps after this, you will appreciate the simple, everyday wonders of our world even more. Because they are not simple at all. They are the result of nature's extraordinary work, unfolding over billions of years. Looking more closely at how light behaves in our atmosphere is worthwhile. It is an astonishing process. Every second, our planet is bombarded by an enormous number of light particles from the sun. They travel through space for many minutes and, eventually, reach the upper layers of the atmosphere. The upper layers are very thin and contain very little air. But even there, the light particles begin colliding with gas molecules. These molecules absorb the light and re-emit it as new rays of light. This process repeats itself over and over again. The deeper the light penetrates into the atmosphere, the more collisions it experiences. By the time it reaches Earth's surface, the light has undergone millions of such collisions, and each collision changes its direction slightly. As a result, light reaches us from every direction. This is called diffuse light. It is what makes our world so bright during the day. What is especially interesting is that sunlight is not actually white, but slightly yellow. Many people think sunlight is white, but if we could see it without an atmosphere, we would notice a faint yellow tint. This is related to the way our sun shines. Stars of different colors shine in different ways. The hottest stars shine blue or white. Cooler stars shine yellow. Very cool stars shine red. Our sun is a yellow star, which is why its light has this color. On Earth, we perceive sunlight as white because our eyes have adapted to it. This is the normal appearance we are accustomed to. But if our sun were placed next to a very hot blue star, the difference in color would be obvious. Another interesting point is how the sky changes throughout the day. In the morning it has one color, in the afternoon another, and in the evening a third. All of these changes are caused by the changing path of sunlight through the atmosphere. In the morning, when the sun is low, its rays must pass through a large volume of air. Most of the blue light is scattered away. The light that reaches us is yellow, orange, and red, which is why the morning sun appears red. As the sun rises higher, the path of the rays becomes shorter, and less blue light is scattered along the way, making the sky appear vividly blue and the sun appear whiter. In the evening, everything repeats in reverse. The sun sets again. Its rays pass through an increasingly large volume of air. The sky once more takes on red and orange hues, and we are treated to a beautiful sunset. But what would happen if our planet's atmosphere were different? That is an interesting thought. If the air were denser, the sky would be even brighter. All the colors would become more saturated, and sunsets would last longer. If the air were different, the colors might be completely different. On some distant planets, the sky could be yellow or pink. Everything depends on the particles in their atmospheres. Scientists believe that other planets with different atmospheres may contain truly extraordinary forms of life. Their sunsets might be blue, their skies green, and their clouds shimmering with many different colors. How amazing that would be! The inhabitants of such planets, if they exist, would surely admire forms of beauty completely different from ours. It is also worth mentioning an interesting phenomenon such as the rainbow. It is one of the most beautiful natural phenomena, and it is also connected to light and the atmosphere. A rainbow forms when sunlight passes through water droplets in the air. This usually happens after rain, when the air is still filled with tiny droplets of water. Each droplet acts like a small prism, separating sunlight into different colors. Each color is bent at a different angle. That is why we see a beautiful arc containing all the colors of the rainbow. A rainbow shows us that sunlight is actually made up of many different colors. All these colors blend together to create what we usually call white light. But they do not disappear. They are always present in sunlight. We simply do not usually notice them. Only under special conditions, such as after rain, can we see that sunlight is actually a mixture of all possible colors. Very rarely, you may see what is known as a halo around the sun or the moon in the sky. These are glowing circles surrounding the sun. They appear under special conditions when there are many tiny ice crystals in the upper atmosphere. These crystals act like small prisms, bending sunlight at specific angles and creating beautiful rings around the sun. Sometimes these rings can be very bright and even multicolored. This is also due to the way light interacts with matter in the atmosphere. Without an atmosphere, such phenomena would not exist. There are no water droplets or ice crystals in space, so there are no rainbows or halos. All of these beautiful phenomena exist only because of our remarkable atmosphere. The aurora is especially fascinating. This marvelous natural phenomenon can be seen in the far northern and far southern regions of our planet. When special particles travel from the sun toward Earth, they collide with the upper layers of the atmosphere. These collisions cause air particles to glow, creating beautiful waves of green, red, and purple light. They move across the sky like dancing curtains of fire. It is one of the most magical sights on our planet. Many people are willing to travel 1,000 kilometers to the cold far north just to witness the aurora with their own eyes. And that is completely understandable. It is a rare and unforgettable beauty. And once again, this phenomenon exists only because of our atmosphere. Without air, particles from the sun would simply rush past our planet unnoticed. Scientists continue to study light and the atmosphere. Every year they learn something new. They discover new reasons why the sky has the colors that it does.
Новые причины, по которым небо именно такого цвета.